concept of a gas in equilibrium. When we have a system, we have the equilibrium state. And what is equilibrium state? Do anybody remember equilibrium state? Equilibrium state is when we have both the solid, the liquid, and the gaseous state together. Condition of equilibrium. So don't forget that when we have the gas, the liquid, the solid, and others, it's written on the box, but in order to give the answer. It's made up of atoms of molecules that are in constant interactions, as we have in slide 5. Like we have water vapor, we have the nitrogen, we have the oxygen, and all these molecules are moving. They are in constant motion. And then we have a state whereby we have equilibrium state. Both the gaseous, the liquid, and the solid together. And that is what that statement means. In gases and liquids, for example, these atoms or molecules, they are not bound into a rigid matrix. Therefore, they are what? They are free to move. They are free to move. They are free to interact. They are free to gyrate. They are free to collide. And they are also free to vibrate. And that is the essence of our study. When we say dynamic, you are dynamic because you are free to move from your room to this place. And in coming, you interact with other colleagues. And then you are free to do whatever you like. The same thing applicable. Just put that at the back of your mind. That what we have in the atmosphere, there are conditions that they were not restricted as you are not restricted before coming to the class. So, same as they are moving, they are colliding, as we are seeing in that slide 5. And then, as they are colliding, they are also rotating. That is, they are moving, rotating either clockwise or anti-clockwise. That one doesn't concern us, okay? And then gyrating, and they are vibrating, they are vibration in the process. So this process mainly leads us to what we call compressibility bodies. Of compressibility of gases, liquids, compared to the solid. We just mentioned compressibility. But in engineering, there are details of mathematical equations that goes with that. But we won't bother ourselves with it. Okay? Is anybody who doesn't get it clear? Do you understand so far? So they are free, and that is why they collide with each other. They are not like human beings that you have eyes. Somebody is coming, even the person is not looking at you. You look at the person, you give way. But they don't have senses like human beings. So they are freely colliding with each other, and as they collide, some stick together. In the process, some separate, break into smaller units, which will not go into the detail of mathematical aspects. And that is what physicists believe, or scientists, that when you hear the rain want to fall, rain is falling, and you are hearing some sound, look, what happened? It is the ice that formed that are really colliding where we have the positive and the negative charges, and then maybe the same charges coming together like that. And in the process, what you see, lightning during the night, you just see bright light like that. So same, that's just the concepts gradually that we are discussing, but those are the basic. You understand? As you have seen in that slide 5, that comprises both gases that is made up of nitrogen particles, each of which has a diverse of energetic states associated with translational, vibrational, rotational degree of freedom, as we have said, that they are free to vibrate, they are free to gyrate, they are free to move, to collide, and interacted narrowly and mostly through collisions. Then, as I mentioned, electromagnetic forces comes in that produces the lightning you are seeing. Okay. Then, our nitrogen N is allowed to approach infinity for all practical purposes. Then we have the statistical mechanics perspective, which is the jargons of mathematics of it. So we are not going to bother, I've said it several times, that we are not going to go beyond this, the details, mathematical aspect. We are not interested. What we are interested in, how this is affecting our environment. That is our major concern. All the other equations, calculus, whatever, let's forget about this.